So today we are on Unit 4, Lesson 3 on angle addition identities. So our learning target, I can use the angle addition identities to find the sum and difference of the angle values. All right, so I've got a question here for you. Does the sine of pi over 6 plus the pi over 3 equal the sine of pi over 6 plus the sine of pi over 3? So basically I'm asking you, can you use the distributive property and distribute sine through the parentheses there? So let's see if that's true. Let's go ahead and let's find the sine of pi over 6 plus pi over 3. So what we could do there is go ahead and get a common denominator. So you got pi over 6 and plus pi over 3. So our common denominator is going to be 6. So if I add that together, I've got 1 pi plus 2 pi, which gives me the sine of 3 pi over 6, which reduces down to the sine of pi over 2. Okay, so that's what it really equals. And then we could actually find the sine of pi over 2 on the unit circle. So remember, this is 0, this is pi over 2. And the ordered pair up here at pi over 2 there is 0, 1. The sine corresponds with the y value in the unit circle, so it's equal to 1. All right, so now let's find them separately. Well, we know what the sine of pi over 6 there is, so again, we can use our unit circle there. So let me remind you of the values on the unit circle here. So this one right here is pi over 6. And at pi over 6 there, you have the ordered pair, the square root of 3 over 2 and 1/2. And then at pi over 3, that's this one right here. The ordered pair there is 1/2 and the square root of 3 over 2. All right, so what exactly is the sine of pi over 6? So if you remember here, the sine corresponds with the y values on the unit circle. So that's 1/2. What's the sine of pi over 3? So that's the y value at pi over 3, which is the square root of 3 over 2. So now that we found what those values there are, we could add them together. So I've got a common denominator. So I could take 1 plus the square root of 3 equals divide by 2, and I get about 1.366. So if this is the value for the sine of pi over 6 plus the sine of pi over 3, and this is the value of the sine of pi over 6 plus pi over 3, are they the same? No, they're different. So does the sine of pi over 6 plus pi over 3 equal the sine of pi over 6 plus the sine of pi over 3? No, they do not equal. So can you use distributive property up there? No, you cannot distribute the sine through. All right, there are some addition and subtraction formulas. You do not have to memorize them, you just have to be able to use them. So there they all are. I also have them, we have them on our Schoology page there under Unit 4. Underneath the notes, there is a formula sheet under there. It'll say Unit 4 identity sheet formulas. And so these will be listed on that sheet. And if you want, you could print that out or have access to it while you're taking the test or while you're doing your worksheets. Or if you want, you could just copy these down and have them available in front of you all the time. So it's up to you how you want to do that. But we're going to be using these formulas. All right. So we are given here that the cosine of x equals 4/5 and the sine of y equals 5/13. So notice that the two angles, the cosine has an angle x and sine has angle y, so they're not the same. They do not form an ordered pair of 4/5, 5/13, okay, because they're two separate angles. So down here it says to find the sine of x. So to do so there, we're going to have to use our nice formula there of sine squared plus cosine squared equals 1. Well, we do not have the sine of x. That's what we're trying to find. We have the cosine of x. It's 4/5. We can go ahead and square both 4 and 5 there, so we get 16/25. Now I can subtract 16/25 from both sides. I'm going to have to get a common denominator. My common denominator is going to be 25. So I have the sine squared x is equal 25 minus 16 there is 9 over the common denominator of 25. All right, so to solve for sine here, we're going to have to take the square root of both sides. And when you take the square root of this right-hand side, it becomes plus or minus over there. So we get the sine of x equals plus or minus, the square root of 9 is 3, the square root of 25 is 5. All right, so it says that x and y are both in the first quadrant. So is sine in quadrant 1? So this is your quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Over here, your ordered pair in quadrant 1 is positive and then positive. So in quadrant 1 over there, your sine corresponds with your y value, and your y values in quadrant 1 there are positive. So we need to pick the positive value. So we actually have the sine of x there is equal to 3/5. All right, cosine of x, we were already given that in the problem. It's 4/5. Tangent of x is sine x divided by cosine x. Well, we know what the sine of x is. We found it, 3/5. We're given the cosine of x. That's 4/5. So we can change it into a multiplication problem. So we can take 3/5 times the reciprocal of 4/5, which is 5/4. And then I can see that these can reduce down here by 5, so they become 1s. So then we end up there with simply 3/4. All right, so that's the x values, the sine of x, the cosine of x, the tangent of x. All right, so over here we're trying to find the y values. Well, we already found the sine of y there, it's 5/13. We need to find the cosine of y. So to do so there, we're going to go ahead again and use our identity there. So we got sine squared y plus cosine squared y equals 1. We have the sine of y, it's 5/13. So we're going to square that. So I can square both 5 and 13, so that's 25 over 169. I can subtract 25 over 169 from both sides. So I get the cosine squared of y equals 1 minus 25 over 169. I can get a common denominator. It's 169. So my cosine squared y is 169 minus 25 there is 144 over 169. Now I can go ahead and take the square root of both sides, and don't forget the plus or minus there. So we end up there with a cosine of y equals the plus or minus. The square root of 144 there is 12. The square root of 169 is 13. All right. So again, we are in quadrant 1. In quadrant 1, your ordered pair here is a positive and a positive. Cosine corresponds with the x values on the unit circle, and they're positive in this quadrant. So we have a positive. So we get just positive 12/13. All right, so the tangent of y is equal to the sine of y divided by the cosine of y. What's your sine of y? It's 5/13. What's your cosine of y? Is 12/13. So then we can change this into a multiplication problem here. 5/13 divided by 12/13 is the same thing as 5/13 times the reciprocal of what's down the denominator. So I can flip that 12/13 there to be 13/12. And then I can reduce these because 13 goes in the 13s here once each. Multiply the numerator, multiply the denominator, and we get 5/12. All right, so now what about the secant of x? Well, we have the cosine of x, so if you remember, secant is related to cosine. It's 1 over the cosine of x. So that's just 1 over 4/5. And so 1 divided by 4/5, the same thing as 1 times the reciprocal of 4/5, which is 5/4. And so our answer there is just 5/4. Or you could just remember that cosine and secant there have reciprocal relationships, and you see that cosine is 4/5. So then the secant of x there, you just have to flip 4/5 there, and you get 5/4. Right? Likewise, cosecant, now this is of y, so the cosecant of y is the same thing as 1 over the sine of y. Or you can take the sine of y and just invert it, or do the reciprocal of it, or I'm just going to write it out. So 1 over 5/13 is the same thing as 1 times the reciprocal, which is 13/5. So I get 13/5. All right, cotangent of y. So cotangent is the cosine of y over the sine of y. Well, what's the cosine of y? Well, we found that on the last page over there, and we found that to be 12/13. The sine of y, we found that, we were given that, that's 5/13. So now we can just go ahead and change this into a multiplication problem by multiplying by the reciprocal of what's down in the denominator. So that would be 13/5. So then I can reduce these down by 13, and I get 12/5. Right, the most often made error on these is people forget which angle they're dealing there with. So make sure if it has to deal with the secant of x, that it's 1 over the cosine of x, and you don't do 1 over the cosine of y. Okay, that's the tricky part on here. All right, so now we're into our new formulas here, and these are the addition and subtraction. Right now we're doing addition ones here. So if you wrote these down, or you pulled up that sheet, that Unit 4 identity sheet there, we have some formulas there for you. And so one of them is a sine of x plus y, and just copy it down exactly the way it is. So the formula here is the sine of x, and I'll write it up here really small. Sine of x times the cosine of y, and then plus the cosine of x times the sine of y. That is the formula. That's what you have to use. It is not the sine of x plus the sine of y. All right, so the sine of x, we found out what that was. That was 3/5. The cosine of y, we found out what that is. That's 12/13. The cosine of x, we're given that. That's 4/5. The sine of y, we were given that. That's 5/13. So then we're just going to use our numerator and denominator. We're going to multiply two fractions here together. So multiply your numerators, multiply your denominators there. We get 36 over 65 plus, multiply your numerator, multiply your denominator. You get 20 over 65. Now I've got my two fractions, and I can just go ahead and add my fractions there together because I already have a common denominator. So I can write down the common denominator and add the numerators. I cannot reduce that down. So there's my answer, 56 over 65. All right, so likewise, for the cosine, you want to use the cosine formula. So the cosine of x plus y, what is that? It's the cosine of x times the cosine of y minus, yes, there is a subtraction sign in here, the sine of x times the sine of y. Okay, just follow the formula through. Don't try to second guess it. Just use what's written down. So the cosine of x there, we already know what that is. We were given that. That's 4/5. We found out the cosine of y there is. That's 12/13. The sine of x there, we found that to be 3/5. And the sine of y, we were given that. That's 5/13. So again, multiply your numerators and your denominators there, so we get 48 over 65 minus 15 over 65. So now I can subtract my numerators there, and I get 33. Write down my common denominator of 65. Can I reduce that down? No. So there is simplified as much as possible. All right, tangent. Tangent, there's a few formulas you can use for this, but since we just found the sine of x plus y, and we found the cosine of x plus y, I would recommend you use this formula, the sine of x plus y divided by the cosine of x plus y. Because the tangent is sine over cosine, we just found these two values, so why not use them? So you got 56 over 65 divided by 33 over 65. Let's change that into a multiplication problem. So diagonally here, we can reduce these down. Multiply your numerator, multiply your denominator. Can I reduce that down? No. So there I have 56 over 33. All right, so we could also simplify using our angle addition or subtraction formulas. So we're going to treat this as if this is the sine of x plus y. Well, there is a nice formula for that. The sine of x plus y there is the sine of x times the cosine of y plus the cosine of x times the sine of y. The sine of x, so x in this case is pi over 6, so we're going to do the sine of pi over 6. The cosine of y there, that's pi over 3. The cosine x there is pi over 6. And y there is pi over 3. All right. So again, we know these values on the unit circle. So there's our unit circle. We're going to put in our angles here that we're trying to find the values at. So then our ordered pair there at pi over 6, we know that to be the square root of 3 over 2 and 1/2. Pi over 3 is up here. And the ordered pair there is 1/2 square root of 3 over 2. All right, so at sine corresponds with a y value on the unit circle. So sine of pi over 6 there is going to be 1/2. That's the y value. And then the cosine of pi over 3, cosine corresponds with the x value at that angle. And the x value at that angle there is 1/2. So then we have the cosine of pi over 6. So that's the x value at pi over 6, which is the square root of 3 over 2. And sine of pi over 3 corresponds with the y value at pi over 3, which is the square root of 3 over 2. So now let's do our math on this. Let's multiply our numerator and multiply our denominator. We get 1/4. Multiply our numerator and multiply my denominator there. So square root of 3 times square root of 3 is the square root of 9, which is 3. 2 times 2 there is 4. We can add our numerator there together. We get 4 over 4, which gives us 1. So that's another way to find that sine of pi over 6 plus a pi over 3. Is to go ahead and use our angle addition. All right, So now this one here, notice we're supposed to use angle subtraction formula. Well, we have an angle subtraction formula for sine. It is, and I'm going to put the xy in here. It is the sine of x times the cosine of y minus cosine of x times the sine of y. All right, so now let's put our values in here. X is pi over 6, so let's put our pi over 6's in here for x. Y is pi over 3, so let's put our pi over 3's in here for our y's. All right, so again, on our unit circle, we've got pi over 6 here. And the ordered pair there is the square root of 3 over 2 and then 1/2. And then up here at pi over 3, we have the ordered pair 1/2 square root of 3 over 2. All right, so sine of pi over 6, sine corresponds with the y value on the unit circle, which is 1/2. Cosine of pi over 3, cosine corresponds with the x value on the unit circle at that angle, which is 1/2. Cosine of pi over 6, cosine corresponds with the x value at that angle. The sine of pi over 3 is the square root of 3 over 2. That's the y value. So now we can simply go ahead and do our math here. So we've got 1/2 times 1/2, multiply your numerators, multiply your denominators. We get 1/4. And then multiply your numerators, multiply your denominators there. Square root of 3 times square root of 3 is the square root of 9, which is 3. And then 2 times 2 there is 4. So I can just 1 minus 3 there is -2 over the common denominator 4. I can reduce that down, and I get a -1/2. So the sine of pi over 6 minus pi over 3 there is simply equal to -1/2. All right, we're supposed to simplify the sine of 15 degrees using angle addition or subtraction formulas. All right, so the only values we know on the unit circle in terms of degrees here, if you kind of look through these, remember this is 0 degrees. This is your 45. This is your 30 degrees. This is your 60 degrees. This is your 90 degrees. And we could keep going around the unit circle. But 15 degrees. Can you think of two angles that you can subtract there that are going to give you 15 degrees? And you want to use the smallest ones you possibly can use. And yes, we can take 45 and subtract 30, and we get 15 degrees. So we're going to say that the sine of 15 degrees is equal to the sine of 45 degrees minus 30 degrees, right? Because the sine of 15 degrees, we don't know what those are, but we know some of these values at 45 and 30. We know what the sines and cosines there are at those values. So let's go ahead, and I'm going to label these. This is your x minus your y, and it's a sine. So let's use our sine formula. So the sine formula here is going to be the sine of x times the cosine of y minus the cosine of x times the sine of y. All right, so now we can just plug our formula, our values in there. So when I'm saying that there, my x is my 45 and my y is my 30. So let's plug them in here. So sine of 45 times the cosine of 30 minus the cosine of 45 times the sine of my y value, which is 30. All right, so the sine of 45 on the unit circle, 45 degrees, the ordered pair is the square root of 2 over 2 and the square root of 2 over 2. At 30 degrees there, that is square root of 3 over 2 and 1/2 for our ordered pairs. So the sine of 45 corresponds with the y value on the unit circle at that angle, which is a square root of 2 over 2. The cosine of 30 corresponds with the x value at 30 degrees on the unit circle, so that's a square root of 3 over 2. The cosine of 45 corresponds with the x value at 45 degrees on the unit circle. And the sine of 30 there is the y value at 30 degrees on your unit circle. All right. So let's go ahead and multiply our numerators, multiply our denominators. Square root of 2 times square root of 3 is a square root of 6. 2 times 2 there is 4. Over here, square root of 2 times 1 is a square root of 2. Over our common denominator, 4. So all we can do here is put this together as one fraction here. So square root of 6 minus the square root of 2, all over the common denominator, 4. So that's as simplified as we can get it. We want to know the exact solution. We don't want to know a decimal approximation on that. So our learning targets was I can use the angle addition identities to find the sum and difference of angle values. And that's what we just did.